evaluate the indefinite integral. Here we have the integral of a plus bx squared divided by the square root of 3ax plus bx cubed times dx. So, looking at the denominator, and what we have underneath the radical sign is the expression 3ax plus bx3. So, we're going to let u equal that. So I'm going to let u equal 3ax plus bx cubed. So now we're going to take the derivative of both sides. So the derivative of the left side is going to be du. And then we got to take the derivative of those two terms. The derivative of 3ax is 3a. And the derivative of bx cubed is going to be 3bx squared. Now, because we took the derivative of two terms on the right side, that means that we have parentheses times dx. So we got to make sure that we include the parentheses around that. Okay. Now, if you notice, what's in the numerator? We have a plus bx squared times dx. Well, we almost got that here. The only thing is that we got to factor out the 3. So this becomes du, which is going to equal 3 times a plus bx squared dx. And now you can see that this represents what we see in the numerator. So therefore, we need to divide both sides by 3. So I'm going to divide both sides by 3. And so therefore, we end up having 1/3 du on the left side, and that's going to equal parentheses a plus bx squared dx. Okay, so now let's go ahead and rewrite this original statement. But what we're going to do is we're going to separate the terms. So we have 1 over the square root of 3ax plus bx cubed times the quantity a plus bx squared dx. And again, what that does is that just shows us what we solved for to substitute. So now let's do the substitution. So we have 1 over, well, we know that this becomes the square root of u times what we get here, which is 1/3 du. So this is times 1/3 du. So now let's factor out the 1/3. So we have 1/3 times the integral 1 over the square root of u du. Okay, so we're going to rewrite that square root of u to be u to the 1/2. So this becomes 1 over u to the 1/2 du. And then we want to write that as a negative exponent. So this is going to be 1/3 times u to the negative 1/2 du. And now we can take the antiderivative of u to the negative 1/2. So we end up getting 1/3 times u to the negative 1/2 plus 1. Now remember, 1 can be anything. In this case, it's going to be 2 over 2 over negative 1/2 plus 2 over 2, and then plus the constant c. So let's go ahead and finish these fractions here. So we end up getting 1/3 times u, negative 1/2 plus 2 over 2 is positive 1/2. And then same thing over here, we have over 1/2 plus c. So when you have a fraction in a denominator of a fraction, we're going to multiply that by the reciprocal of what's in a denominator. So we're going to end up getting 1/3 times the reciprocal of 1/2 in a denominator is 2 over 1 times u to the 1/2 plus c. Okay, so now let's go ahead and rewrite this exactly the way that they had it at the beginning, because they had a radical sign. So what we're going to do is multiply the two fractions. So 1 times 2 is 2, 3 times 1 is 3, And then we have times the square root of u plus c. And now the last thing that we want to do now is to now bring back the substitution of u, which is 3ax plus bx cubed. So then our result is going to be the following. 2/3 times the square root of 3ax plus bx cubed plus c, and then there is our result.